All right, welcome to another lesson here. So today, what we're going to talk about is square roots and what we do to multiply them. So, and also divide. So we need to talk about some vocabulary first. And one thing we need to say is that we have a whole number component and a radical component. The radical part is what's under the square root. So keep in mind my symbol on the computer only stops it here, but it would continue on as long as I needed to. All right, so we have whole number and we have the radical. All right, so here's one example where we're going to talk about multiplying the same radicals. So the square root of 3 times the square root of 3. So when we multiply square roots, we just multiply the numbers and keep the square root. So 3 times 3 is 9, and we keep the square root. Now in this case, the square root of 9 happens to be 3. All right, so let's look at another example. The square root of 2 times the square root of 2 is the square root of 4, which happens to be 2. The square root of 4 in this example times the square root of 4 is the square root of 16, which happens to be 4. So what is the shortcut that you notice? When we multiply two identical radicals, the square root disappears and only one radical number is left over. So if we look at this one, the square root of 81 times the square root of 81 is just going to be 81. Right? Now, sometimes we're going to have radicals that have whole numbers in front. So what we want to do first is multiply whole numbers by whole numbers. So 2 times 1, there's a 1 out in front of this. 2 times 1 is 2. Square root of 3 times the square root of 3 is 3. So that's going to give you an answer of 6. All right, now in this problem, I tried to highlight it to help you guys see this better. So 3 times 4 is 12. Square root of 2 times square root of 2 is 2. And now we multiply these two numbers together. All right, so 5 times 6 is 30. Square root of 4 times square root of 4 is 4. Multiply those together, you get 120. Right, and the same thing would hold true even if the numbers are bigger, you still follow the same rules. Okay, so now what happens when we divide? Well, in a perfect world, it would be nice if things divided nicely like this. So the square root of 3 divided by the square root of 3 would cancel out, leaving us with an answer of 2 in this problem. So that's a very simple answer. Now, similar to the multiplication, if we have whole number components, if they can divide, if they can simplify each other, then we're going to do that. So 12 divided by 4 is 3. And in the square roots of 3, anytime you have identical square roots of a number, in this case square roots of 3's, they cancel out. And so in this problem, you're left with just the answer of 3. So if we look here, this is 20 divided by 5, which is 4. And then the square root of 3 has nothing to divide by. So it's just 1. So it's square root of 3 over 1. All right. So now what happens when we have two radicals and they're not the same? So the shortcut is this, and this does not always work, but when it does, it works great. Look at the bottom square root and ask yourself if there's a factor of the same number that can go into the top number. So can 3 go into 6? And it can, and it goes in 2 times. So we break up the square root of 6 into the square root of 3 and the square root of 2. And the reason we do that is that it now allows us to cancel out these two square roots, leaving us only with the square root of 2. Okay, so again, step 1, does the square root of 6 go into the square root of 30? Yes, so it'd be 6 times 5. The square roots of 6 will cancel out, leaving you only with the square root of 5. All right, now what happens if we have a whole number? Well, the same steps still apply. We divide the whole numbers, which gives us 2, and then we break the radicals up like we've done in the previous problems. So you're left with the whole number of 2 and then the square root of 2. And in this case, that is your answer unless it's asked for in decimal form. Okay, so now here's an example where nothing divides. Okay, so we can't take this and divide it because we have a whole number and a radical, and those don't mix. It's like oil and vinegar. So what we do is called rationalize the denominator. So what we're going to do, and this works in every problem in which there's a square root on the bottom, we're going to multiply the top and the bottom by the square root of 3, or whatever the square root on the bottom is. Whatever that value is, we're going to multiply the top and bottom by it. So earlier we talked about how the square root of 3 times the square root of 3 would give us an answer of 3. And by doing this step, we eliminate the square root on the bottom, and math people don't like square roots in the denominator. Now up top we have 6 times the square root of 3. So now in this step, then we have to go and say, okay, do we need to do anything with whole numbers? And in this case we do. 6 divided by 3 is 2. Let's look at this example. So the shortcut step again is does 6 go into the top number? It does, right? Oh, sorry, it doesn't, because we have a whole number and we have a radical. So we're going to rationalize the denominator. So square root of 6 times square root of 6 gives us 6. And then now we have a whole number which divides into 5. And then what I forgot to type here is the square root of 6. So this answer should be 5 from the red and then the square root of 6 from the black. All right, let's try a couple examples here and see how we do. So look at example 1. If we look at example 1, square root of 6 times square root of 6 is 6, and then 4 times 1 is 4. So we multiply those together to get 24. Okay. All right, number 2, forget the negative sign for now. The square root of 5 times square root of 20, we're going to multiply those together and we get the square root of 100. And the square root of 100 is actually 10. Okay. So that's just 2 quick examples on how you would do these things. Go ahead and try these other examples, and if you have questions, feel free to shoot me a message. If you have the calculators, you can also type this in to check your answer, but you really shouldn't need a calculator if you know your basic multiplication facts. But if you want to check it with the calculator, feel free to do so. Okay. So anyhow, hopefully this video helped you out, and I'll see you on the next video whenever I can figure out how to work this. All right, see ya.